We will now talk about a very cool new feature in Houdini 18, guided RBD simulations. So for now, I'm going to show you this scene I have set up, and then we can build it together from scratch. So take a look at the building. This building is pre-fractured. I can press spacebar W to see the wireframe. So I haven't added that much detail just to make the simulation faster, but it has enough detail to show you the point. So let's press play on the animation and take a look. So notice how we have, first of all, the first floor falling down, and then the slab of the second floor falls down. And if you take a look at this fourth input, or actually fifth input of the RBD bullet solver, I'm connecting a very simple simulation I did with a few boxes. So I'm just letting these boxes fall down with gravity. And these low resolution boxes are pulling down the RBD pieces of the high resolution building. So I will again display my building. This time I will template the low resolution simulation. And again, take a look at the animation. I have another example. This time I will connect this second geometry I created. So just for you to take a look, this is a hand animated geometry. So I'm just bending the same boxes that I simulated here on the third branch. And now this is going to drive the simulation of the fracturing building. So let me activate the RBD bullet solver and press play. Actually, let me change this attribute and press play. So now we have part of the wall moving towards the right, and it eventually crumbled down, which looks very cool. Okay, so now that you have a very good idea of what we're going to create, let's do this together in a new file. Okay, so here we are with a scene that contains only a camera and a geometry node with a building. And if I dive into the geometry node, the only thing that I have currently is the Dan building. This is an OTL or an HDA that will be provided with the course files. Just in case you haven't done this yet, you can go into File, Import, Houdini Digital Asset, and find the HDA that you want to install. In this case, you can browse and go into the OTLs folder that will be provided. In there, there's the Dan building 1.1. So just double click here and you will be ready to load this. So in my case, I have done this before, so I will just cancel, but I will create another building again. Just type tab and then DAN building. So I will start with this geometry and will fragment only the pieces that I'm interested in breaking. So let's first of all create a box. And in my case, I want to break this part near to the camera, the right part of the building. So I will template the building, select the box, and press enter to be able to manipulate it here in the perspective view. So I will make it much taller, of course. Probably I will make it go up to the third floor. And probably wider. Okay, I think this is enough. So I will scatter some points. So you can use VDB from polygons to create a fog volume. So disable distance VDV and enable fog volume, and then add a scatter node. And now I will connect an RBD material fracture node to my building. So I will enable the RBD material fracture. And one thing I want to do is use my own scatter points. So here under the RBD material fracture node, I will disable this fracture level 2. And on fracture level 1, I will change the scatter points to 0. And then I will connect the scatter points I created here to the fourth input of the RBD material fracture node. And just make sure to click on input point. Now I forgot to reduce the number of points in the scatter node. By default it will create 1000 points, but I think that's too much. Let's check. Let's go with 1000 points and take it from there. So select your camera, and right off the bat we're going to connect an RBD bullet solver. So an important thing here is remember that the RBD material fracture creates some constraints. In this case I won't use those constraints, so just connect the first input and the third input. Select your RBD bullet solver, and we know the entire building will just fall down. By default it doesn't have a ground plane, so let's do that first. Select your RBD bullet solver, go to the ground tab and turn on ground plane. So right now the only thing that will happen is the entire building collapses. So remember, we need to configure an active part so the rest of the building holds still. So let's add an RBD configure node. Let's connect it right below the RBD material fracture. And let's make sure to turn on active. And we're going to use a bounding box to select the active points or the active pieces. So click on the use bounds. And this time we're going to use, instead of a bounding box, a bounding geometry. And if you take a look here at the RBD configure node, the fourth input says static bounds geometry. I will connect this to the box we just did. We can use the same box geometry. So now whatever is inside this geometry should be active. The rest of the pieces should be inactive. So let's go back to our RBD bullet solver and press play. And now everything is working as expected. The building will hold and only the pieces that we fractured will fall. So now let's take care of the guiding geometry. So in this case, again, I will make use of this same box. So I will be reusing the same geometry. I will make some room here. Make it visible. And what I did is I created a line and just with a Voronoi node subdivided so I could simulate each piece individually. So let's do that. Let's create a line. In this case, I can center it with a box. So I'll go back to my box, click here on the center, copy the values, and then paste them back into the origin of the line. So paste values. And actually I can bring down the origin to 0. Also the height, we can use the same height of the box. So select your box, copy the size in Y, and then paste back the value on the length of the line. So in this case we can paste a relative reference. And For the line, we can increase the number of points. I think I used about 10 points. And we will use this to fracture the box. So let's add another Voronoi fracture. Connect the box in the left input, the line on the second input. And this is what I got as a result. So let's first of all create the bending geometry, and then we'll take care of the simulation. So let's add a bend node. Connect it to the Voronoi fracture. You can press enter just to take a look at the manipulators. So right now it's on the wrong axis. So I need it to go through the y-axis. So let's take care of a few parameters for the bend. So first of all, I'm going to take the line length. I'm going to copy this value. And in the bend parameters, I'm going to look for the capture length. I'm going to paste this value here as a relative reference. The capture direction needs to be on y. So change y direction to 1 and z to 0. Also, we need to center the bend on the box. So again, we can use the line's center or origin. Let's copy these values and paste them on the bend origin as a relative reference. And I think now it's working as we expected. So yeah, let's create some keyframes and then connect this to our rigid body simulation. So I'm going to frame 48 and create a value of 0 for the bend. So you can alt click on bend to create a keyframe. And then on frame 96, I will change the value to say minus 80 degrees and press enter. So in my case, I have the auto key on. I like to generate keyframes every time I change a value. So you can turn on auto key. If you don't like this mode, well, just change your value and again, alt click on the bend parameter to create a new keyframe. So I think we're now ready to create our simulation. Go back to my RBD bullet solver and I will connect my bend box into the 5th input of the solver. So I will go back to frame 1, select my RBD bullet solver. I'll press escape just to turn off the visualizer, and maybe we can template the bend object just to see what's happening here. So right now, if you press play, let me go to my camera view. If you press play, nothing new will happen. The pieces are still crumbling down because even though this geometry is connected, you need to be specific and tell the RBD bullet solver that you want to use a guide. So I'll go back to frame 1 and here under guided simulation, make sure to turn on use guides. So now let's press play and let's see the result. So the pieces are holding together. So internally, the RBD bullet solver is generating constraints that hold the pieces together where this volume exists. And this is looking quite good. Just using the defaults looks nice, but let's take a look at some of the parameters that are helping this work and maybe talk about some of the pitfalls that you can find and how to fix them whenever you're using the guided simulation.